In this video, I'm going to introduce additive notation for groups. So you may recall that a lot of the notation that we use with groups is what I would call multiplicative. That is, the notation is sort of inspired by the idea of a multiplicative operation. So multiplicative notation includes things like the fact that when we compose two group elements, we usually write the product as A dot B or just AB. When we write that, we're usually writing something that we typically think of as pertaining to multiplication. Okay, what about the way that we write the identity element in a group? The way we normally write the identity element is, well, sometimes we use the letter E. That's the one typically used in Gallien's book. But we can also use the symbol 1. Now, that doesn't mean that we're talking about the number 1. It just means that we're talking about some element that we think of as being like a multiplicative identity when we're thinking about the operation being multiplication. So that's another example of notation that's sort of evocative of the idea of multiplication. Now, what about inverses? I'm just going to keep track of what I'm writing down here. This is the operation. This is the identity. Okay, what about inverses? Well, the way that we usually write an inverse of an element in a group is we say A and then exponent minus 1. Now, that doesn't mean that we're actually thinking of that necessarily as an exponent. It just means that we are writing down the inverse of an element, and we're writing this down in such a notation that if we were to compose A inverse with A, we would think, oh, that's sort of like multiplying A to the negative 1 times A to the 1, which gives me 1. And what about exponents, or powers of a group element? Well, the way that we write down powers of a group element is we say, well, we can start with A to the 0, which is the identity, and then we have A to the first, which is the same thing as just A, and then we have A squared, A cubed, and so on. And again, when we do that, what we have in the back of our heads, even if our group operation isn't multiplication really, is the idea of multiplication. So now, we are going to develop a different notational system for groups that is useful for us to think about in some other situations. So this is called additive notation. And we're going to use this mostly when we talk about abelian groups. We will not usually use additive notation when talking about a non-abelian group. And sometimes when talking about abelian groups, we'll still use multiplicative notation, especially if the operation really is multiplication of numbers. But we're going to use additive notation sometimes because that's actually a really useful way of thinking about a lot of abelian groups, because a lot of the time the operation there really is addition, not multiplication. So how do we denote the operation? Well, given two group elements A and B, we just write the composition of those as A plus B. Or what about the identity? Well, if we want an identity that's sort of logical in this setting, then we need to think about what kind of object we could add to something and not change it. Well, if we wanted to do that, if we wanted to have an object which we can add to something without changing that thing, we would probably use this symbol, 0, the additive identity. So again, that doesn't necessarily mean when I'm talking about an abelian group that the thing that is the identity is 0. It doesn't mean it's like the number 0, but it's useful to call it 0 because if we're going to talk about the group operation as though we are adding things, then what reminds us of adding nothing or adding something that doesn't change the object we're adding to? It's 0. Okay, what about inverses? So for notation for inverses, I need something which, if I add it to A, gives me 0. Well, when we think about our experience with algebra, the most logical thing to go there is the opposite of A, or negative A. So I'm going to use negative A, or as often as possible, I'm going to call that the opposite of A, because I always hate saying negative because it makes it sound like that object has to be negative, and it doesn't have to be. But that's what I'm going to call the inverse, is this little negative sign and then A. And then finally, what about powers? Now this is the tricky part because we defined exponents for a group to be the result of composing numerous copies of the same element under the group operation. So what does that look like over here? Because it's not going to look like powers anymore. It's going to look like what happens if I compose a bunch of A's under addition. Well, what do we call that? If I have n copies here, then we're going to call that n times A, because you might remember in grade school, what does this mean? What does the notation n times A mean? we always sort of classically took that to mean n groups of A each, or just n copies of A. So we're going to call that n times A, but what makes that a little bit tricky is that this looks like multiplicative notation, but it's actually not, because what we're doing here is not a group operation. It's not a group operation. What it is it's a symbol for repeated addition. So if I have a group, and I'm using additive notation to describe what's going on in that group, and I use the times symbol, I'm using that in the sense of n copies of A. Or, by the way, if I want to talk about negative powers, or I guess in this case a negative multiple of A, I can do that as well. So for example, if I want to compose 3 copies of the inverse of A, then I would do this. I'll put these in parentheses just to avoid any confusion there. So what do we call that? We would call that negative 3 times A. So if I have a group where we're using additive notation, I can actually define n times A. And again, I'm using the word times kind of reluctantly there, but n times A, where n is any integer. And I'll just zip down here and define that. So the way we define this is, first we define 0 times A to be 0. Okay, now this is really sneaky because this refers to the integer, because I'm saying this many copies of A, and this refers to the group element, the identity. So those symbols 0 don't mean the same thing. So to honor that, I'm going to just put a really bold 0 here, even though it's going to look really sloppy. Okay, those should not be the same thing. And then what else? Well, if I want to define n plus 1 times A, that is equal to n times A plus another A. This is assuming that n is greater than or equal to 0. And finally, if I want to define negative n times A, where n is still a natural number, then that's defined to be n copies of the additive inverse of A, or just the inverse of A. Okay, so that's an intro there to the idea of multiplicative notation, which is what we're most used to at this point, versus additive notation, which is in the future what we're going to use more of for abelian groups. All right, so a lot of this is just determined by context. You'll see me use the symbol plus or the symbol negative where a negative doesn't seem to belong, or the symbol 0, and you'll realize, oh, hey, he's talking about an abelian group, and he's doing this in a context where we're thinking of the operation as being like addition rather than being like multiplication, even though the operation may be neither of those things.